Hi, we're just having a look today at graphing equations in the standard form. That's this one here of ax plus by equals c. It's a bit different to our normal form of y equals mx plus c, which this form is known as the graph intercept method, the gradient intercept method. And this one, the standard form. So what we're going to do firstly is just look at some background thoughts about it. The two very important fundamental principles about how we go about graphing in this form. So we'll look at that. And the first is, when we examine the y-intercept, if we've got a line that cuts through it, for instance like that one, it cuts through and we know that there's a y-intercept, and that y-intercept can be determined, and it looks like there it's about 2.3 or thereabouts. Okay, but while we describe that with one single point, in reality, or one single number, in reality it is a coordinate point, and it should be prefaced by 0. That is, the x coordinate is 0 where the y value is 2.3, and that can be seen to be true for any point along here. So for instance, if the line passed through here, the x value remains at 0, but now our y value is 5. If our line passed through this point here, again the x value is 0 and our y value is -3. So that therein lies our first thought, which is in fact that to find our y-intercept, that it will occur when x equals 0. Now conversely, if we were to look at this point here, our x-intercept, we notice that again, while it's seen to be one number, in this case approximately -3, the y value for that is 0. So to describe that point accurately, we should really describe it using the two numbers -3, 0. And in fact, regardless of where the line passes, if it passes through this point or this one or this one, the y coordinate's going to be the same. So in fact here, x coordinate 5, y coordinate 0 for this point, 2, 0, and for this point here, -5, 0. So you can see the x-intercept occurs when y equals 0, and that becomes the second fundamental and important piece of information we're going to rely on. So the x-intercept occurs when y equals 0. Now I'll pause the video and tidy the screen and continue in a sec. Okay, I've tidied up the screen now, and we're going to see if we can graph this equation of 2x minus 3y equals 12. And this is, as you can see, in the standard form. So we're going to use this first bit of information where the x-intercept occurs when y equals 0 in order to find our x-intercept. So this is the way we set it out. So we rewrite our equation, but where we see y, we will replace it with the value 0 because y equals 0. And then we solve this linear equation. So 3 lots of 0, 0. So 2x equals y. And by methods of backtracking, we can say x equals 6. So our x-intercept occurs at the point 6, 0. Looking now at our y-intercept, as we've found out previously, y-intercept occurs when x equals 0. So this time, when we rewrite our equation, we will substitute for the value of x equaling 0. Now 2 lots of 0 is 0, so we'll be left with -3y equals 12, and therefore y equals -4 as we divide through. So our point here for the y-intercept is going to be 0, -4. Sketching that graph then, as with any straight line graph, requires us to identify those 2 points and plot them. So our first point is the x-intercept, which occurs at 6, 0, which I'll mark in here. And the other point that we know is the y-intercept, which is 0, -4, which I'll mark in. Now joining those lines carefully and extending through them, putting the arrow on either end, and writing the equation next to the line, sees that graph complete. Okay, so we'll move on now and do another one, very similar to the first. And again, we're going to find the x and y-intercept in order to find the graph. So we'll start initially with the x-intercept. And remember y equals 0. when the x-intercept occurs. So we rewrite our equation, except when we get to the y portion, we replace it with 0. 7 lots of 0 is 0, so 3x will equal 5, and therefore x will equal 5 on 3. Our x-intercept then is a 0.5 on 3, or approximately 1 2/3, 0. The y-intercept, replace x with 0. The 3 lots of 0 drops away. And we've got that point there, which can be written as 0, 5 on 7. Recognizing that x equals 0, and we place it in there. Sketching up our axes, labeling, putting the points of reference, so 5/3, 0 will be our x-intercept, and our y-intercept is 5 on 7. And then joining the dots as best we can. Oops. And finally labeling the line with the equation. And we're done. Okay, copy these examples into your book and get on with the questions that I've